Hi, in this video we're looking at integration with partial fractions. Don't be surprised if at this stage you're feeling quite overwhelmed by the variety of different things we have to do with integration. Why can't it be as simple as integration was last year? I hear you asking. Yep, last year's integration was fairly simple. There was only one approach that you needed to take, and you used that on the situations that you were given. This year, however, it's different. There are many different situations, and you have a variety of different tools available to you to integrate the functions. Now, in the last video or previous video, we looked at the integration of natural logs, and we recognized those because they had a fraction, and the top of the fraction was the derivative of the bottom of the fraction. If we take a look at the example that we've got here, unfortunately, it doesn't fit that pattern of the natural log because the top is not the derivative of the bottom. Derivative of 2 of x squared minus 1 is 2x, and that's not what I've got in the top. So what I'm going to have to do is go and use some of the knowledge that we gained earlier this year, knowledge on partial fractions, and we're going to split up this fraction into two pieces. Now, how do I recognize that this is a partial fraction? Well, if I go and take this function, 2 over x squared minus 1, I could always rewrite that as 2 over x plus 1, x minus 1, in which case I could write it as a over x plus 1 plus b over x minus 1. Having done that, I'm now going to try and figure out what a and b are. In order to do that, I multiply everything through by x plus 1, x minus 1. My left-hand side is going to be left at 2. My right-hand side is going to be a brackets x minus 1 plus b brackets x plus 1. And I'm going to look at this when x is equal to 1. In that situation, what do I have? I have that 2 is equal to, well, I'm not going to get a value for a, am I? Because that's going to be 1 minus 1. It's going to give me 0. But I'm going to get a value for b. I'm going to get 2b over here. And so that allows me to rearrange this and say this is b is equal to 1. If I go and look when x is equal to minus 1, what do I have then? I'm going to have 2 is equal to a times minus 2. And in this situation, I'm going to be able to say that a is equal to minus 1. So I now have a way of being able to rewrite this function. I'm going to have a way of being able to rewrite the integral. So the integral of 2 over x squared minus 1 dx, I can write that as a, which was minus 1, the integral of minus 1 over x plus 1 plus the integral of 1 over x minus 1 dx. Having done that, I can split these two up. I can say this is the integral of minus 1 over x plus 1 dx plus the integral of 1 over x minus 1 dx. And that now looks like a natural log situation because the numerator is the derivative of the denominator. In the first one, I just need to take out that minus 1, and then I'm going to have the natural log of x plus 1. And for the second one, I'm simply going to have the natural log of x minus 1, and to that I'm going to add c. And so here is my answer, natural log of x minus 1 minus the natural log of x plus 1 plus c. And there I have my derivative, my integral of that function that we started out with. Obviously, the partial fractions can be more complicated than that, so if we take a look at this example here. This is an example of a definite integral, but it's going to follow the same sort of process. So once again, I'm going to look at my function 1 over x minus 5. I'm going to write that as a over x plus b over x minus 5. And if I multiply through everything by x brackets x minus 5, I'm going to be left with 1 is equal to a times x minus 5 plus b times x. And when x is equal to 0, then I'm going to have that 1 is going to equal a times minus 5. In other words, a is going to be minus 1/5. And at x is equal to 5, then I'm going to have that 1 is equal to 5b. In other words, b is equal to 1/5. And so this function that I started out with, x brackets x minus 5, that can be rewritten as a, which is going to be minus 1/5 of x, plus b, which is 1/5 of x minus 5. Having split the function up in that way, I now go and look at the integral. So I'm going to look at the integral between 1 and 4, and I'm going to just flip these around the other way. So this is going to be 1 over 5 times x minus 5 minus 1 over 5 times x dx. Now hopefully you'll notice that 5 is a factor, 1/5 is a factor of both terms there. So I will remove that 1/5 out in front, and I've got the integral between 1 and 4 of 1 over x minus 5 minus 1 over x dx. And, oopsie, I'm going to need more space. And I must forget my equal signs. So what am I going to have now? I'm going to have 1/5, and the integral of 1 over x minus 5, well, that's going to be the natural log of x minus 5 minus the natural log of x, and that's going to be between my maximum minimum of 1 and 4. So what do I have now? I have 1/5, the natural log, and this is where this absolute value sign is going to come into play, because I've got 4 minus 5, that's going to be the integral of the absolute value of minus 1 minus the ln of 4. And from that, I'm going to take away the ln of 1 minus 5, that's going to be minus 4, minus the ln of 1. Now, we need to remember, what is the ln of 1? You'll go reaching for your calculators to figure that out. Yes, the ln of 1 is 0. So I'm going to have brackets over here, I can forget that first term. This is simply going to be minus the natural log of 4 minus, and here I'm going to have the natural log of 4 as well, because the natural log of absolute value of minus 4 will simply be the natural log of 4, and ln of 1 is 0. So I've got minus ln 4 minus ln 4, and so that's going to give me 1/5. Try writing 1/5. 1/5, open your brackets, minus 2 ln 4. And if I want to be clever about that, I can say this is 1/5 of ln 4 to the minus 2. So it's going to be 1/5 of the natural log of 1/16. And there is my final answer, the answer of my definite integral. The last example, I'm not going to work on that one. You have done enough work on partial fractions to be able to deal with this. Just to remind you that this function, x plus 4 over 2x minus 1, x plus 1 all squared, that's going to be written as a over 2x minus 1 plus b over x plus 1 squared plus c over x plus 1. Don't forget that last factor that we've got over there. So hopefully you can appreciate that Cambridge are likely to bring questions to do with partial fractions into this work on integration, because that way they can test two skills within one question. So be prepared for this. Go and practice your partial fractions. Go and practice your integration with partial fractions. Goodbye.